right. So this is going to be a little weird. This really aggravated me. It's been so long since I've used fractions like this, and let alone the way they're using fractions. Some of them are easy. Some of them are no-brainers. Here's a percentage. You got to figure out a percentage. And then they make some weird ones that are like real weird percentages. I think there was one that was a real weird percentage in there. But I want you to hang with me. And if there's anybody out there, maybe I'm the weird one inside here that it's just I've never used any of this stuff practically in life. I mean, I've been a stonemason, I've been a carpenter, I've roofed, I've done landscaping. I studied quantum physics. And we're about to get in it on this first question about quantum physics and Bernoulli. There are a lot of things in terms of here. There's a lot of variables missing.
Welcome, YouTubers.
Time's missing. The amount's missing. There's nothing there to allow this situation to not cosmologically collapse.
That should mirror
inside of
what
it.
You'll see
you know, why would I want this number in the form of a fraction when I have it in the form of a whole number already?
Again, the ASVAB
I would say,
computer adaptive test.
If I know that there's 6 people, if I know that there's 60 people,
regardless of how good you may be at math,
you know that this would be 3/4 would be 75. So 6 goes into 10 once with a remainder of 4.
Correct.
And so it's 1.40 whatever.
And in light of that,
okay, so that's how many people you have. You have 1.4 people, huh?
Showing you what some of those very simple questions could look like.
You know, maybe a recipe.
Always, you're not permitted
you know, but
to
in the end of this, it's kind of marginal, really. I mean, it's like, wow, Betty Crocker, the things you're dealing with in here.
Try not to make use of
Of course, I know that this is the answer.
Likewise,
as you break that down over 100, it's going to drop it down to the 100 spot. 0 or 10, 100, thousands, millions, which is functional, which is great. It's to say which function inside here is basically saying, well, from here I'm just inverting it. I'm saying I know the problem to take it to a whole number. I have 6 things over 100 people, right? I got 6 products and $100, right? I got 6 products and I get $100 out of it. What do I get? What do I get for? No, wait. How does that work? I got 6 products, and I need to divide it by 100 things. It would be 0.6. 100 people, 100 tasks of what it does. Now, you tell me how far 6 cents gets you in the real world. How about 6 seconds? And why is 100 or 10 the arbitrary model in there? I don't have an Alice. I don't have a Bob. Basically, you have cosmological collapse in here. I have X and Y, but I have no Apple. I have no system inside of there where that's functionally practical. Now, in itself, tenths, hundredths, thousandths, that's a reasonable system.
Let's say,
but for what? Again, you know, I had 6. I had 6 things, and I need to divide them by 100 things.
To write any number as a fraction,
I could only put 6 things in 100 by breaking down this 6 into a smaller fraction than it is, because it's in a whole number.
Again,
if it's a half an apple, that's not exactly the same value.
So that's the approach we're going to take to this one.
As a 0.6 of an apple, if I needed them to be in whole form, right? And nobody's going to want 0.06 of an apple, right? Here's a whole apple, right? 0.5 would be half an apple.
None of them match this. And the reason
if it was a tenth, it'd be a tenth. I could cut it into tenths,
our next
right?
task is to clear this decimal. And that's actually pretty easy to do.
And how do you evenly cut that in geometry with supersymmetry?
And multiply it by 100,
all right,
which
so
will clear this decimal, as you'll see in just a second.
The 6
to
cuts.
Keep proportionality, we're going to have to do the same thing to the denominator. So let's start with the simple
I'd have to make 100 cuts on a hexagonal pattern.
Let's think about how we're going to do
right, and maybe if I followed that geometry, I could get even shares as I cut the apple into 100 shares. Maybe that'll make sense. But what in the real world do you ever need to do that for? Maybe quantum physics? Show me something on the ASVAB here where that's practical. A gear ratio function? Sure, but you already have a gear ratio function. You have 5 teeth on a gear, and a smaller gear, right? And so I could have 3 gears here, and as long as the
that's that one.
The symmetry was right, or at least the scale of the symmetry was right, I could stay to a 1 to 2 or a 1 to 2 ratio. And every time one tooth hits, one tooth hits this, this will make 2 full rotations. One full rotation on this will make 1 full rotation. One full rotation on this will make 2 full rotations on that. That's sensible. That's an easy algorithm to analytically work out. I should be able to figure out. I should be able to draw all the parts and do those things. Somebody's going to say to you, why is that not necessary? I did say D.
Says a club has 36 members. If each member donates 12 items for an auction, how many items will there be in the auction?
Okay, so 12 times 36.
This is a simple case of multiplication.
36
members are each bringing 12 items.
With
so
1 over it, that's 72. So we got 2 answers that stand out. Drop the 0 on 72 and multiply 1 times 6.
3 times 2 is 6, plus 1 is 7. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 6 is 6. 1 times 3 is 3.
Yeah, I should be right. I'll be writing this stuff down later. But it should be 4 or D, I think.
6 is 13, so you'll bring down a 3, carry a 1.
Because there would be a 3 there. So it eventually ought to hammer it out. Plus, you should write this stuff out. And who doesn't have a calculator nowadays? That's a bit disconcerting. I mean, 12th grade, I really don't know how much of this stuff they really teach anymore.
4 over 10 plus 3 over 100. That is to say, we want to add these two fractions together. So we have 4 over 10 plus 3
we are talking about 2 very different systems.
100.
Couldn't you individually solve this, turn it into a real number? Again, 3/4 is 75. So I know that's going to be good. And you're going to say, well, at least twice. There's 8. So 2 with a rounder of 2. That's not going to work. So 2.02, that's 5. So 2.05 would be the whole number. And here 3 goes into that.
Such that
60
they have
times?
the same denominator.
60, that's 90.
Pretty easy to do.
60, 66.
And multiply it by 10.
And
10 by
inside
10
of there.
100. So we can see that if we multiply this denominator by 10, we'll have the same base
Who come up with these rules? And how do I analytically describe that in the real world?
So
if you can show me a situation, or teach it in school, you could say, that would be the analytical design and what this is. I'd be very happy with you. No, I'll get this. Again, this helps me with my process of understanding it. So 40 into 100, that's 80, the remainder of 20.
This is how you add
that's
these.
2.0. Yeah, I'm still good here. 2.05, which would be 20 remainder over. And this is going to be 66, I do believe.
Of course, is 43.
66.01 or something like that.
If possible, we would attempt to simplify this, but that's not going to be necessary. We can see the correct answers right there. It's A.
Oh yeah, there. But you see, that is a very weird way to do it without something physical in hand.
280 binders for attendees and another 31 binders for presenters. How many total binders did the planner put together for
30,
attendees
so that's
and
100,
presenters?
that's 3.
So this is a simple addition. We have 280 plus
1,
31.
3, 1, 1.
0
yeah,
plus
C.
1 is 1. 8 plus 3 is 8, 9, 10, 11. So we're going to drop down a 1 and carry a 1. And 2 plus 1 is 3. So we can see that this one is going to be C.
Those numbers, adding pallets together,
right.
pattern. I can do Excel. I can do pattern calculators, like pattern tread coefficients. No problem. I can get the program down.
72 cans sold. What percent of the cans of popcorn stock were sold that weekend?
All right. So, the store stock 150 cans. So roughly half. So it looks like C. So you'd say, well, half of 150 is 75. If you times 75 times 2, it gets you, or 75 times 2 gets you 150. The only thing close enough in here is this, but they might trick you on that one, where you want to do the long division on this one. But still, this number is smaller than this number, so you know it's a whole number, right? That is a guaranteed thing. You gotta do that.
Similar. We have 2%,
except 5%, for when there's
48%,
you got another number plus a fraction where you have to add 10 to it, like in that last
75.
problem.
So 75 over 150 would be exactly.
Again, the reason this works is because maybe that comes up in life. You don't have to multiply it. Where did the 10 extra things come from in that last equation?
In light of the fact that the answer choices are very spaced out, logically speaking, we can confidently say C is going to be the correct answer.
Because I need this one to be 100 in the 100 area. I'll always go to the bigger bottom decimal. So if it's 10 and 100, you always go to the hundreds just to make the fraction
I'm
larger.
I'm simplify this fraction as much as
maybe
possible.
That.
To say, I'm look
and again,
to divide 72
I have two very separate areas of time. And we're going to go back to that one real quick because I think we got this. Yeah, we got that one here. Well, let's go back to that last one for a minute.
Over 1.
Okay. Again, we have 4 over 10 here. This is its own system. And again, you would multiply it like that and say 4 goes into 10. When you do the long division onto this, 2 times for 8 and 0.05, right? So 2.5. I got, if it was money or if it was pieces, if I can roughly get 4 pieces out every 10 minutes a stone. That means I'm roughly 4 pieces every 10 minutes. I'm roughly getting 2.05 whole rocks done. Now there might be multiple processes in the fractal of what the real world is for a situation like that. I have to burn stuff, I have to cut stuff, I have to operate stuff, and in no way inside of there would I be okay with this. And again, as soon as I knew this was the problem, then I could say, okay, so I need to open this up in steps. I need to have 100 minutes. And only in that situation would this equation work. Otherwise, I would reduce this down to 10. How many ever I'm getting here, because these are so close by operations, why would I still take time or dollars and correlate them to the pieces? Maybe they're vastly different pieces, right? This is 4 pieces of... what are you going to say, 8-inch steps, right? And these are treads. Or, well, this would actually be treads, and this would be steps, right? So I can only get 3 steps done every 100 minutes, but I could get 4 treads done. 8-foot, 2-inch thick bluestone treads, the way I do the operation, or stack and board, or whatever the value is. When it analytically doesn't make sense like that, because you have this huge cosmological collapse in terms of the information that are multivariable, multi-domain, where I'm not really in multi-Perkins, multi-domain battlefield, where the values of x and y inside here, ax plus bx inside here, are 2, is basically 2, which is one of the STEM problems right there. But again, that's a great way to analytically describe the problem, but we don't have Alice or Bob. Well, I don't even know if Alice and Bob are involved in here. And even if it was wildlife or trees, you could still say, well, a person cuts down trees, people hunt animals, people go around and chase them, go try to pet bears and alligators. But at no point in time in here can I think of any practical way in which to function that material to want to do that. There would need to be a very physical reason. Hydrogen wave function. All right, so I'll argue hydrogen wave function to you, but the level of mathematics that go into that, S order, P orders, and things like that, plus the molar mass and the weight and mass of an atom, and come on, I mean, you're asking some very heavy stuff, and even in that context, because that context is not applied in this form, it would very specifically relate back to hydrogen as a wave function that reduces this down to 1 or 0, right? It's 1 and 0, or -1. Is this before the decimal, after the decimal, in terms of a whole number? Pensrow would talk about inside of this situation, potentially. I don't know if he actually would or not, but that could be an idea of this situation passing through the Pensrow. Now, the only thing I can say today is the stock market, realistically. It's like it's got a dip, it's down, it's up, it's up, it's down. By being down, it's a negative for me, but it's a positive, or it's a positive for me because I'm going to buy the dip, but it's a negative for you because it's not gaining money like this stuff is today. And even at that ratio, it still doesn't apply functionably because there's no real functionable parts. An apple has a common mass amongst apples. You could say there's a range, because I know there's one of the problems inside here that has a range.
Again, if possible, we would attempt to simplify
I'm going to take
this.
a break right here. Hopefully you understand what I'm trying to tell you.
That's not going to